Welcome to Physical Science, Section 2.1, Types of Forces. Let's start with some definitions of force. When a force is applied to an object, its shape might change. We call that deformation. Even when you put your hand down against the desk, the shape of your hand changes. A force has been applied, the deformation. Or the motion of the object might be affected. It might move. If it is moving already, its direction of motion might change, or it might stop moving, like when you throw a ball and catch a ball. There are two general categories of forces. First are contact forces, those that require the agent that causes the force to be in direct contact with the object. You're very familiar with these. Examples are pushing, pulling, squeezing, friction, contact forces. The second category of forces are field forces. Those are that act at a distance. Gravity, magnetism, electricity. They don't have to be in direct contact in order to work. This is an example of contact and field forces. On the left are the contact forces, friction, elastic compression, horses pulling a wagon. On the right are your field forces, gravity, magnetism, electricity, okay? There are four forces of nature. The one that we will only deal with in this class is gravity. Gravity holds the stars, planets together and depends on the mass of the object. That's a test question. Gravity depends on the mass of the objects. We also have electromagnetic, which are responsible for binding atoms and molecules together. We have a strong force that holds neutrons and protons together. And we have a weak force that produces instability in a nuclei. Those three we will actually deal with second semester when we do chemistry. Force constants. Each of the forces that I described just on the slide before has a constant given to it. It has a solid number that is its amount of force. The one you need to deal with is gravity, the gravitational field strength on Earth, aka Earth's gravity, aka acceleration due to gravity on planet Earth, is 9.8 meters per second squared, or 9.8 meters per second. That's a constant, and you need to memorize it. The four forces that we are going to study. The first one is tension, and it's abbreviated FT. F stands for force, T is tension. It's going to be a horizontal or vertical contact with your object. FG is gravity. Gravity always goes down. Friction is abbreviated FF. It always goes opposite the motion. Okay, goes in the opposite direction of the motion. So if a book is sliding to the right, friction goes to the left. And friction causes the object to slow down. Finally, we'll talk about a normal force, which is abbreviated FN, which also is called the support force. This is always with an object on any surface, and it comes up from underneath the surface. So here are examples of forces and their effects. FT, again, is a push, pull, grip, or squeeze, like hanging a picture on the wall, pushing a block across the table, pulling your luggage down the airport runway. Gravity makes things come down. Weight is the force of gravity. Weight is the force with which gravity attracts an object down to the earth. Weight pushes down. In order for the ball to be caught by the mouse, gravity has to pull it down. FF is friction. Again, you have some rough surfaces like carpet and gravel that have a lot of friction, or you have very low friction like ice and tile. Also part of FF is going to be air resistance, air friction. Okay, aerodynamic cars have very low air resistance, low air friction. A parachute has very high air friction. Finally, the normal force. The normal force, we call it the force that is always with you. It's the support force. It is normal for you to be able to sit in the chair and the chair holds you up. It's a normal force. The normal force comes up from underneath because it is supporting you. So when we analyze forces, a force is produced by an agent. So whatever made the force, that's your agent. A force acts on an object. That's called the receiver. So whatever you're actually looking at to study, the force is being applied to it, that object is the receiver. And finally, the force causes something to happen. This is an effect. Force diagrams are formatted of F for force, the type, tension, gravity, friction, normal, the on, meaning what object is it acting on, and then a by, meaning what caused the object, or what caused the force. So what you do is you reduce the object to a single dot. You label all the forces acting on that object in that format, force, type, on, by. Remember that the normal force is perpendicular. That little symbol stands for perpendicular to the surface. And that gravity always goes down. So let's look at an example. In this example, we have a downward force of gravity and it goes straight down. Even though the boy is going to be sliding down the slide, gravity still pulls him straight down. So we have the force of gravity on the boy by the earth because earth caused the gravity. We also have the force of friction, and it goes diagonal up to the right because the force of friction is on the boy by the slide because, believe it or not, he is going slower than if he just fell off the ladder. Finally, we have the normal force, and it's going to go diagonal up to the left because it is perpendicular to the slide. It's the force of normal on the boy by the slide. Okay, he's not going to sink through the slide and hit the ground. So the actual force diagram would look like this. The force of normal on the boy by the slide, the force of friction on the boy by the slide, and the force of gravity on the boy by the earth. Let's try another one. We're going to look at the block on the shelf. So make the object into a single dot. Look for and identify forces acting on the object. And you only have 4 forces, so check them all. Then you're going to draw the force arrows from the dot and label the arrowhead force type on by. So this little block becomes a dot. And I notice that I have gravity because gravity is in every situation. So I draw a downward arrow for gravity. I notice that it's sitting on something, so I have a normal force. It's going up. It's not moving, so I don't have any friction, and nothing is pulling or pushing on it, so I don't have any tension. So I can label the downward arrow of FG block earth, and we would read that as the force of gravity on the block by the earth, and FN block table, the force of normal on the block by the table. We'll do far more examples in class. Thanks for watching.